So the point 5, -2 is locating the standard position angle. So I'm going to just find that point on the circle. So I'm going to go 5 over, about 2 down, somewhere around here. And again, we're just looking at the proportion of 5 and 2. And that's locating an angle here. Okay, I'm going to draw my little reference triangle here. And putting in the positions. Okay, so it's 5 and -2. So the angle, the first thing it's asking for is the radius. So we're going to use Pythagoras. And since we're given two sides of the triangle, we want to leave this in exact values. So we're going to do 5 squared plus -2 squared square root, and that's going to be square root 29. So square root 29 represents the radius, and we want to use that exact value. Then using these exact values, we're going to give this values for sine. So sine goes with the y. So it's going to be -2 over root 29. Cos goes with x. So 5 over root 29. And tan is our slope. It's a slope, negative slope, because it's sloping down. So -2 over 5. Okay, and then finding the angle theta. This is where now since this is not a special triangle, we need to use a calculator, and we're going to introduce decimal values into this problem. Okay, so when we solve for theta, I'm going to write it in its arc form, or the inverse form. So I'm going to just use maybe the tan in this case. Okay, we could use tan, cos, or sine. So I'm going to use the inverse tan. So we have inverse tan of the ratio. The input is a ratio. The output is my angle. Okay, so when I do the arctan, -2 over 5, I end up with -21.80 degrees. Okay, so this is going to be -21.80 degrees. Okay, so looking at this, we have to make sure that we have the right quadrant. So this angle is in the quadrant 4. The theta that we solve for is also in quadrant 4. Now there are times where you will be asked to find the positive version of that angle. Okay, so I want to have the same position, but the positive. If I were to write that in the positive form, I have to do 360 minus the 21.80, or more accurately, we should really say the position -21.80. We're going to start here and add 360 to that. Okay, and so we end up with 338.20 degrees. So that's going to be our coterminal angle, and that's a positive version of that same position. Okay, so we do have to consider that we have to make sure that this is in the right quadrant, because we've seen in the past that depending on the ratio, depending on the position, sometimes we might want to have the other angle that represents the same slope. So remember that we use the tan. So the tan is slope, and that same slope does have a different position over here. Okay, so we have to make sure that we're not finding that position and we're finding this position right here. Okay, so here is another problem where we're given cos ratio is 3 over 4, and we need to find the other trig ratios. Since we're given the cos ratio in exact values, we have two sides of this triangle. Okay, so I'm going to draw this in. The cos goes with x. So my x to my radius, I'm going to say is 3 to 4. Now, this is a bit of a problem because I don't know, although we know that the x is positive, we don't know the y. We don't know if the y is positive or negative. So there are actually two positions that I have to consider here. So there's another position down here that has the same ratio of positive 3 over positive 4. Okay, so there's two possibilities that I'm having to consider. So here the sine theta, well, let's solve for the third side here. So 16 minus 9 is going to be root 7. So sine theta could be positive root 7 over 4, or it could be negative root 7 over 4. So I'm going to write that in. So it could be root 7 over 4. That's the positive version. Or, since there is another position, there's a second position that has the same cosine ratio, we could also consider that it could be negative root 7 over 4. Same with the tan. The tan here could be from this black position, which could be positive slope. So in this case, it's going to be positive root 7 over 3. But the tan could also be in the red position here, which gives us a negative slope, which is negative root 7 over 3. So because this quadrant's not specified and cosine, positive cosine can be in two different quadrants, we have to consider both possibilities. So even for theta, when I solve for theta here, when I do the arc cos of 3 over 4, I end up with 41.40 degrees. So 41.40 degrees. Now the calculator only ever gives me one angle, so I'm going to call that one theta 1. But using symmetry, I can work out the red position of this. So the red position, I know it could be, I'm going to call that theta 2, and that could be negative 41.40, or if I need to measure it in the positive direction, this is also the same, and this is not, these are two different angles here, theta 1 and theta 2, but theta 2 could be written as a coterminal angle as 318.60 degrees. Okay, so these are equivalent positions. These are two different positions here, and theta 1 and theta 2 indicate two different positions. So there are two different possibilities for this cosine ratio, and that's the case for all the ratios. If we only have the ratio, we have to consider that there's two positions that they can take up in the circle. So that's the difference between the example 1 and example 2. This one here, we know exactly the right position, although the tan, we have a slope of negative 2/5. That slope could have two positions. We know that it is only in one position because a quadrant is known in this problem. Here, we've been given the cosine ratio. We have no indication of the quadrant location. And cosine, and in fact not just cosine, but the cosine and tan, can take on two different positions. Each ratio can take two different positions. So this cosine ratio can be in quadrant 1, quadrant 4. Sine ratios can be in, quad has a symmetry across the y-axis, so it could be symmetrical this way. And tan has rotational symmetry, so it could be opposite symmetry. So we have to be very careful to make sure that we know, if we know the quadrant, we give one answer. If we don't know the quadrant, we have to give both positions, both possible positions. So how are example 1 and 2 different? Example 1, the quadrant is known. Only one position is considered. Okay, so that's very important. In example 2, quadrant is not known. So two positions must be considered. Okay, so this is a very important aspect of circle geometry, is that we may need to consider two positions because of the symmetry of the circle.